A picker stands in a massive distribution center surrounded by endless rows of 20-foot shelving. Every 8 seconds, a paper pick list or handheld screen directs a human body to step down another long aisle, walking up to 12 miles in a single shift just to retrieve small plastic items. In traditional logistics, human movement accounts for more than 60% of total picking time. That mechanical friction creates a strict limit on how fast a facility can operate. When orders surge, the classic aisle layout fails under its own physical geometry. Dozens of workers crowd into the same high-velocity aisles, creating human traffic jams and causing retrieval errors. Expanding capacity under this legacy model requires building wider facilities, increasing footprint costs, and pushing walking distances beyond human endurance. The floor plan itself becomes the primary bottleneck, locking capital into empty aisle space that generates zero revenue. To break this limit, logistics engineering discarded the concept of human travel entirely. The arrival of goods-to-person automation flips the physical architecture of the warehouse upside down. Instead of sending a person down a wide corridor to find a box, specialized automated storage systems compress inventory into dense, contiguous blocks. Inventory comes directly to a stationary worker, eliminating wasted walking time and fundamentally changing how floor space is measured. At the center of this shift is high-density grid storage technology, pioneered by systems like AutoStore. The physical design replaces sprawling aisles with a solid aluminum cube made of vertical cells stacked several stories high. Plastic bins sit directly on top of one another inside these tight shafts, leaving virtually no air gap between rows. This structural compression allows facilities to store up to 4 times the inventory within the exact same footprint. Operating across the top surface of this dense structure are fleets of autonomous robotic shuttles. Moving along a 2-dimensional track grid, these shuttles travel along X and Y coordinates at high speed. Powered by precise electric motors and guided by optical sensors, each shuttle stops above a designated cell, lowers wireless mechanical grippers down into the stack, and pulls out the target inventory bin within seconds. Managing this vertical stack requires intelligent software driven by algorithmic slotting. Because bins are stacked on top of each other, accessing a deeply buried item requires a robot to dig out overhead bins and temporarily place them on neighboring cells. To keep latency low, the system constantly tracks item velocity. High-demand items are automatically reshuffled to the top layers during slow periods, ensuring fast access during peak order windows. Once a shuttle retrieves the requested bin, it transports the container across the top grid to an integrated port station. Here, a human operator or picking robot stands at a fixed, ergonomically optimized workstation. The software presents the target item directly at waist height, illuminated by precise pick-to-light lasers. The operator picks the single requested unit, drops it into an outbound shipping box, and confirms the action with a quick scan. This continuous feed alters human output metrics instantly. At a traditional aisle-based packing station, a worker might process 50 to 70 items per hour. At an automated goods-to-person station, that speed rises to over 400 items per hour. The stationary design removes physical strain, lowers injury rates, and drives operational accuracy to 99.9%, virtually eliminating picking mistakes across high-volume fulfillment cycles. Removing wide travel aisles reclaims vast amounts of real estate previously wasted on empty space. Traditional warehouses dedicate up to 50% of their floor plan strictly to human and forklift access lanes. Under a GTP architecture, these corridors vanish. The entire central footprint becomes a consolidated block of active inventory, allowing companies to build smaller facilities or fit far more stock inside existing urban structures. Shrinking the physical footprint changes where fulfillment centers can be built. High-density storage lets operators move deep into city centers where land is scarce and expensive. By fitting standard regional storage capacity inside smaller suburban industrial spaces, companies cut the physical distance between inventory and the end customer, driving down last-mile shipping costs and shortening delivery windows. Beyond horizontal space savings, automated goods-to-person layouts maximize vertical clear height. Standard forklift systems struggle to operate safely above 30 feet, leaving high ceiling volume completely unused. Aluminum storage grids stretch continuously up toward ceiling trusses, using structural frames that support heavy loads with complete stability. Every cubic foot of internal volume becomes productive storage space. The shift to fixed workstations also transforms workplace safety on the shop floor. Heavy forklift traffic, high-reach order pickers, and falling pallet hazards are isolated away from human workers. Operators remain inside protected, air-conditioned zones where lighting and motion are engineered to prevent repetitive strain injuries. The physical burden shifts from human bones and joints to industrial steel and software loops. Maintaining high throughput requires structural redundancy across the robotic fleet. If a single robotic shuttle suffers a drive failure or sensor fault, neighboring shuttles automatically reroute around the disabled unit. The central fleet software dispatches a service shuttle to tow the unit off the active grid into a dedicated maintenance bay, preventing facility-wide bottlenecks and keeping operations active 24 hours a day. Energy dynamics undergo a significant transformation when switching from wide-aisle lighting to dark grid automation. Robotic shuttles operate effectively in complete darkness and unheated airspaces, dramatically cutting climate control overhead across the primary storage block. Furthermore, modern shuttles use regenerative braking to recover kinetic energy during deceleration, feeding power back into internal battery cells during every directional shift. Modular grid construction allows operational scaling without shutting down active operations. Facility managers can expand the storage block outward by locking additional aluminum framework onto existing cells. Adding capacity simply means dropping more standardized robotic shuttles onto the top track, providing direct, linear scalability as seasonal volume spikes during peak retail months. Connecting dense storage grids to outbound shipping lines requires complex mechanical integration. High-speed conveyance loops, automated tote stackers, and automated packaging machines must match the rhythm of the picking ports. If an outbound packing line stalls, picking stations quickly back up, forcing software algorithms to slow down grid retrievals to maintain balanced flow across the facility. Real-time tracking of every individual bin creates total visibility across the supply chain. Weight sensors built into picking ports verify item counts instantaneously during every pick. If a single item discrepancy occurs, the inventory control software flags the specific bin for an immediate automated audit, sending it to a quality station before errors cascade down into customer orders. Advanced algorithms optimize how orders are batched and presented to human pickers. Instead of handling one order at a time, a single bin retrieved by a shuttle can fulfill items for multiple open customer orders simultaneously. The software sequences retrievals so that a single shuttle movement maximizes order completion rates across dozens of packing totes lined up at the station. In temperature-controlled food and medicine distribution, goods-to-person automation provides dramatic cost reductions. Cooling a massive open-aisle cold storage warehouse requires immense electrical energy. Compressing frozen inventory into a tight grid reduces the thermal volume that must be chilled, while keeping human operators outside the extreme cold inside climate-controlled picking booths. Retrofitting an old warehouse with modern goods-to-person systems presents steep engineering challenges. Floor slabs must be leveled to micro-inch tolerances to prevent structural flex across the grid framework. Fire suppression pipes, power drops, and overhead ductwork must be re-engineered to clear the top path of running shuttles, turning legacy facilities into high-tech robotic hubs. The economic equation shifts from ongoing variable labor expense to upfront capital investment. While installing an automated grid demands high initial investment, the long-term reduction in cost per unit picked creates rapid payback cycles. Facilities reduce long-term operational expense while building a scalable physical asset that operates with predictable cost structures. As manual walking roles disappear, the nature of warehouse labor undergoes a structural transition. On-site staff pivot from physical material handling to system supervision, robotic maintenance, and software quality management. Mechanics and automation technicians replace traditional pickers, shifting the workforce toward higher-skilled industrial roles. The acceleration of internal picking loops transforms total order cycle time. Orders that previously took hours to locate, pick, and transport across a giant facility now move from click to pack slip in under 10 minutes. This rapid processing velocity gives operators the power to extend cutoff times for same-day delivery services across major market areas. The density of goods-to-person systems also provides high operational security and inventory protection. Enclosing inventory inside a solid block eliminates product damage from forklift impacts and prevents unauthorized access to high-value electronics or pharmaceuticals. The grid functions as both a mechanical storage system and an integrated physical vault. The next evolution of goods-to-person automation merges grid storage with autonomous picking arms. Equipped with high-resolution vision systems and dynamic tactile grippers, robotic arms pick individual items directly out of retrieved bins without human intervention. This complete automation loop connects storage, selection, and packaging into a single continuous mechanical sequence. The transformation of warehouse layouts through goods-to-person automation represents a permanent shift in how physical space is organized. By replacing sprawling aisles with intelligent grids and mobile shuttles, industrial logistics has redefined efficiency from the ground up. This convergence of mechanical engineering and software intelligence ensures that the modern warehouse is no longer a passive storage shed, but a dynamic, high-speed engine of global commerce.